Hi, so in today's lesson we're going to start a new topic, topic 27, functions. Before we get to that, I just want to briefly talk about the previous topic, topic 24, sine and cosine rule. Now if you've completed all the lessons up to this point, you will know that we've done the first 4 of these bullet points. You will have done a check-in task, you will have emailed that to your teacher, and they will be able to give you feedback on that. Now we're not going to do the remaining 4 of these. And please rest assured that all your teachers know that. So all teachers of Year 10 are aware that we're not going to cover those 4. The reason for that is because they're quite visual things. The idea of being able to apply a 3D Pythagoras theorem question, you need to be able to visualise it, which is going to be quite difficult without a teacher kind of demonstrating that to you live. So we're going to leave those 4, and as I say, teachers are acutely aware that that's the case. So getting back to today's lesson and functions, we're going to target this first one using the function notation today. So title of using function notation, and then I'd like you to copy down what's on the board at the moment. Now the point I want to make about a function is this. If you look at these top 2 equations here, you've got y equals 5x plus 3 and y equals 3x squared minus 1. Now they're both equations that are y equals. So if you imagine you're trying to talk about those, there might be a 3rd equation, a 4th equation, all that are y equals, it becomes quite complicated to explain which one you're talking about, because this is y equals and that's y equals. So with function notation, we can give these equations a name, and we would call this one f of x, is how you say that, or g of x. And so this just allows us to explain which equation and which function we're talking about. Now the original notation of function comes to f of x, so that's where the f comes from. Now in reality you can use any letter you like, so we're going to use some different ones as the lessons go on, but m, n, it doesn't really matter. But we start with f of x and g of x. So I would copy those down and just explain it's a different way of saying y equals, okay? Now what it also allows us to do is it allows us to substitute in a bit quicker and a bit neater. So if I wanted to know the value of y when x equals 5 here, I would write that as work out the value of y when x equals 5. But with function notation, we can do that quicker. So we're looking at something like this. So again, I'd like you to copy this down. But what we've got here is we've got a function f of x equals 2x plus 7. And we want to work out f of 4. Now what that means is work out the value of this equation when x equals 4, okay? And we can just write that neatly as this. So what we're looking to do here then, and this is the key bit really, is whatever is in this bracket gets substituted into the expression, the function rather, where x is. So we're going to say f of 4 here is 2 times 4 plus 7. Now throughout this whole topic we must make sure we follow BIDMAS, which means we need to multiply before we add. So 2 times 4 is 8, plus the 7 gets you 15 there. So f of 4 is 15. Same sort of thing with the next example. So f of negative 1. So we replace x here, we substitute that in, we'd substitute in negative 1 into where x is. So 2 times negative 1 plus 7. 2 times negative 1 is negative 2, plus the 7 is 5. Same thing here. So f of 0, 2 times 0 plus 7. That's 0 plus 7 equals 7. And we can do it with decimals as well, or fractions, whatever we want to put into this function is fine. So 0.3 in where x is, so 2 times 0.3 is 0.6, plus 7, so 7.6 is your answer there. So copy those down and just explain that this is the most important part of this first part, is that this number here is being substituted in where x is. Okay, I'll just show you a different example. So we've gone for h of x this time. As I say, that the letter is not that important. The letter will be given to you in your exam, f, g, h, whatever it needs to be. So we're looking for h of 4 here. So we substitute in where we see x with 4. So we've got 3 times 4 squared, take away 5. Now again, I must emphasise the fact that you have to use BIDMAS when you're calculating sums like this. So make sure you square the 4 there before you times by 3, okay? So 4 squared is 16, times by 3 is 48, take away 5 is 43. Same thing for negative 1. So h of negative 1, 3 times negative 1 squared, take away 5. Now be careful when you're squaring a negative number. You can put that in a bracket if you like to remind you. Negative 1 squared is 1. 3 times 1 is 3, take away 5, negative 2. H of 0, again, 3 times 0 squared, take away 5. Nothing there, so take away 5 is negative 5. And finally, again, with 0.3, 3 times 0.3 squared, take away 5. 0.3 squared is 0.09. Times by 3 would be 0.27. Take away 5 is negative 4.63. So that would be your answer there. Okay, I'd now like you to write those down, copy those examples in, and then have a go at the questions in the booklet for lesson 1. And make sure you email your teacher if you've got any questions. Okay, thank you.